Now I am going to explain about frequency response of linear phase FIR filters. Now how the FIR filters are linear. So we have to consider four different cases. Case 1 is symmetrical impulse response when n is odd. That is the first case. Second case is symmetrical impulse response when n is even. Third case is anti-symmetrical impulse response when n is odd. Fourth one is anti-symmetrical impulse response when n is even. So those are the four different cases we have to consider for linear phase FIR filters. So let us consider the first case, that is a symmetrical impulse response when n is odd. Okay, so let us consider h of e power j omega is equal to, this is a Fourier transform of impulse response. This is impulse response h of n, that is summation n is equal to 0 to n minus 1 h of n e power minus j omega n. So I am considering n is odd. Let us take n is equal to 7. Consider n is equal to 7. Then substitute in place of n. Okay. So in place of n, substitute 7 minus 1. Okay. N is equal to 0 to 7 minus 1 h of n e power minus j omega n. Okay. So that is nothing but n is equal to 0 to 6. So now you have to expand the terms. Okay, so for n is equal to 7, the center of symmetry is alpha is equal to 3. That means what? N minus 1 by 2. N is 7. 7 minus 1 by 2. Alpha is equal to 3. The center of symmetry is what? Alpha is equal to 3. Now I am expanding based on the center of symmetry. N is equal to 0 to 2. H of n e power minus j omega. This is one term. And the center of symmetry is at which number? 3. H of 3 e power minus j3 omega. So I am writing this as separate. Plus summation n is equal to 4 to 6. Remaining 4 to 6 h of n e power minus j omega n. Okay. So this is 0 to 2. Now let us consider in terms of capital N. So how to write 2 in terms of capital N? That is n minus 3 by 2. So n minus 3 by 2. So here n is what? So n we are getting as 7 minus 3 by 2. 7 minus 3 by 2 means 4 by 2. That is equal to 2. So I am getting 2. N minus 3 by 2. N is equal to 0 to n minus 3 by 2. Okay. Now 3. How to write 3 in terms of n? N minus 1 by 2. 6 by 2 is 3. Same 3 as n minus 1 by 2. Now 4. N plus 1 by 2 by 2. 7 plus 1. 8 by 2 as 4. And n minus 1. 7 minus 1 as 6. H of n e power minus j omega. Okay. Let I am considering n is equal to small n is equal to n minus 1 minus m. So in this m is equal to what? N minus 1 minus n. Okay. So see the limits n plus 1 by 2 to n minus 1. In order to equate these two limits, so I am considering first limit is what? N plus 1 by 2. Now I am considering n plus 1 by 2. So in this equation, substitute n value as this one. N plus 1 by 2 substitute. Okay. So m is equal to equation enti n minus 1 minus n value and this n plus 1 by 2. So you are getting n minus 3 by 2. Now up to n limit is what? N minus 1. Next. Now consider n is equal to n minus 1. Then m is equal to n minus 1 minus n minus 1. Here the limit is what? 0. Okay. 0. Now h of e power j omega is equal to summation n is equal to 0 to n minus 3 by 2 h of n e power minus j omega n plus h of n minus 1 by 2 e power minus n minus 1 by 2 omega plus m is equal to, now we are getting the limits n minus 3 by 2 to 0. Now I am writing it as m is equal to, so here the limits is what? M is equal to 0 to n minus 3 by 2 h of n e power minus in place of n. So what is n? This is n. I am writing n value as this one. Okay. Now next step is replace m with n. Then I am writing n is equal to 0 to n minus 3 by 2. So here also in place of m I am writing m. In place of m writing as n. For symmetrical impulse response, what is h of n? H of n is equal to h of capital N minus 1 minus n. This is for symmetrical impulse response. Okay. Now, h of e power j omega is equal to summation n is equal to 0 to n minus 3. H of n e power minus j omega n plus. Okay. So, h of n minus 1 by 2 e power minus j n minus 1 by 2 omega. So, in place of n, you have to write n minus 1 by 1 minus n. Now, in this equation, common e power minus j omega of n minus 1 by 2. So, if you common, so remaining terms in this first term is summation n is equal to 0 to n minus 3 by 2 h of n. So, multiply these two, you are getting e power minus j omega n. Okay, here e power j omega of n minus 1 by 2 minus n plus h of, so this is a common term. Okay, and remaining term is what? H of n minus 1 by 2 plus summation h n is equal to 0 to n minus 3 by 2 h of n. So multiply these two terms, you are getting e power minus j of n minus 1 by 1 minus n. Okay, so after that, in this equation, write the exponential e terms in one brackets, h of n as remaining one. Okay, h of n is equal to this one and this one. Okay, remaining is what? So in these two terms, summation n is equal to 0 to n minus 3 by 2, h of n is common. Okay, common that term. So in remaining terms, so e power j omega n minus 1 by 2 minus n plus this part is e power minus j omega n minus 1 by 2 minus n. Okay, plus h of n minus 1 by 2. So it is in the form of cos. Okay, so 2 cos, you have to write this term as 2 cos omega of n minus 1 by 2 minus n plus remaining part is h of n minus 1 by 2. Let us take, let p is equal to n minus 1 by 2 minus n. This term you have to write, take it as p. That implies if you substitute n is equal to, what is the first limit? N is equal to 0. N is equal to 0 means what is the p value? P is equal to n minus 1 by 2. So in the same way, for n is equal to, next term is what? N minus 3 by 2. What is the p value? So p is equal to, substitute n minus 1 by 2 minus n minus 3 by 2. You are getting the value as 1. Now you have to change the limits. P is equal to 1 to n minus 1 by 2. P is equal to 1 to 1 minus n by 2. And 2h of, what is n? What is n? So p is equal to n minus 1 by 2 minus n. Then in this, what is the value of n? N minus 1 by 2 minus p. So substitute that value. And cos omega is, what is this value? This value is p. Cos omega p plus remaining term is h of n minus 1 by 2. Now change p to n. Again you have to change from p to n. E power minus j omega n minus 1 by 2. Now you have to change p as n. N is equal to 1 to n minus 1 by 2. Again p as n. P as n. Okay. So plus h of n minus 1 by 2. Now, so this term you have to write it as same. Summation n is equal to 0 to n minus 1 by 2. A n cos omega n. A n cos omega n. Now, if you apply summation, okay, so here a of 0 is equal to, if you substitute n is equal to 0, if you substitute n is equal to 0, you are getting only a of 0 is equal to h of n minus 1 by 2. Okay, now this part is an. An is equal to 2h of n minus 1 by 2 minus n. Okay. Now, so you have to consider h of e power minus j omega is equal, e power j omega is equal to, so e power minus j omega n minus 1 by 2 into h bar of e power j omega. Okay, you have to write this as h bar of e power j omega. Here h bar of e power j omega is nothing but what? Summation n is equal to 0 to n minus 1 by 2 e of n cos omega n. Okay, so this is h bar of e power j omega. So total h of e power j omega can be written as the magnitude response multiplied with phase response. Okay, h bar of e power j omega into e power j of theta of omega. So this is the phase response and this is the magnitude response. Okay, h bar of e power j omega. So h bar of e power j omega is nothing but this term. Whereas theta of omega is nothing but, as we already know, theta of omega is nothing but what? Minus alpha of omega. So here omega alpha is equal to what? Alpha is equal to, in this term alpha is equal to what? N minus 1 by 2. N minus 1 by 2 into omega. Okay, so this is phase angle. Now h bar of e power j omega is a real and even function of omega. Now this can be written as, now this is nothing but magnitude of h of e power j omega, which is equal to h bar of e power j omega, magnitude of h bar of e power j omega. Now the angle of h power e power j omega is what? Theta of omega. Theta of omega means alpha of omega. Okay, now when this condition is satisfied, then h of e power j omega is greater than or equal to 0. So here we have 4 different figures. The first figure is magnitude response and second figure is h bar. This is a 0 phase response. h bar of e power j omega is nothing but what? It's a 0 phase frequency response. Okay, this is a 0 phase frequency response. And theta of omega and the angle of mod of h of e power j omega. Now see, so compare magnitude and 0 phase frequency response, these two. Here the 0 phase magnitude response contains pulse in both positive and negative side, whereas in h bar magnitude response of h of e power j omega is strictly follows the frequency response in the positive side only. Okay, so now the angle is C. So you have to draw the dotted lines. So if you get, so here there is a positive response. This is the positive peak. Okay, so you have to draw the dotted lines. So where you get the positive peak. Okay, so now whereas in h bar of e power j omega, you can get the peak, the pulse at both positive and negative side. The phase here, the phase angle is linear because of both positive and negative pulses. So by this graph, this is a linear phase FIR filter. We can say this filter is a linear phase FIR filter. Okay, now angle of e power j omega is nothing but theta of omega. Okay, when h of e power j omega is greater than or equal to 0. Now if you take, this is minus alpha omega plus pi. Now when h bar of e power j omega is what? Less than omega. So if we add pi, then h bar of, that is 0 phase frequency response, which is less than 0. Then theta of omega is equal to alpha of omega. Okay, so in the same way, when h of e power j omega is less than 0. Okay.
And then pass chata namanu.